Okay, so on the side right here, let's write down some exponent rules. If I have, so let's use some numbers. So when I multiply, what do I do to the exponents? Yep, you add them. So this is 2 to the 7. Your base number stays the same. All right, what about when I divide? Like this. When I divide, what do I do to the exponents? Sydney? Subtract them. So then this is 2 to the 3. What if I do exponent raised to another exponent? Gavin? Multiply. So then 2 to the 6. What about 2 to the 0? Anything to the power of 0? Yep. 1. That's right. All right. Now this is the actually. Oh, I'm looking at this. Did you guys do negative exponents in grade 9? So those of you who did negative exponents in grade 9. Okay, you did not do negative exponents in grade 9. So what about the rest? Negative exponents. So for example, I'll give an example and then you guys tell me if you know what to do. So for example, 2 over 3 to the exponent negative 1. Who knows what this equals? Ming Yan? Right, which is 3 over 2. So negative exponent tells you to flip the base. Does that make you... Okay, so some of you are thinking, oh yeah, and then like, huh? All right, so how many of you knew this? Okay, that's fine. So we'll do more. I'll teach it as if like nobody knew about this then, because it was a change in the curriculum. It was in the grade 10 curriculum, and then they moved it to the grade 9 curriculum. So I'll give you guys the benefit of the doubt that your teacher didn't go over it with you guys. So don't worry about the negatives yet. We'll get into it more later. Okay, so those are the exponent rules that you need to know. Let's do a quick example right here. Number 1, negative 9 to the exponent 0. Right, think carefully with this one. Resven? Right, it's negative 1. Why is it negative 1? Miss, didn't you just say right here that exponent 0 equals 1? Right, but because there's no brackets, right? So only the 9 is raised to the power of 0. So that's why it's negative 1 and not positive 1. Okay. This one, number 2. Gavin? 1, that's right. Because 4 minus 3 is 1. 1, you raise it to a million, is still 1. Okay, this one right here with the brackets. Hey, Adam? 1. Because of the brackets, that means the whole number, negative 4, is raised to the 0. And my computer is running out of battery. And then what about this, number 4? Resmed? 0. Yeah, because 1 minus 1 gives you 0. Okay. We were talking about these rules, so let's try number 9 right here. Okay, who has an answer for me? All right, if you have an answer, put up your hand. Okay, Brian? Okay, so Brian says negative 6 to the power of 12. Is this right? Is this what you mean? Okay. Anybody else have a different answer? Okay, Ming Yang. Brackets. That's right. All right, my base right here is -6 in brackets, just like how we said in example 3. Brackets do matter. All right, just like in this example right here, we see that brackets do matter, so I do need brackets around this -6. Right? How did we get the exponent 12? We're multiplying, so we add the exponents. So 4 plus 9 gives me 13, and then 13 minus 1. When there's no exponent, it's still an exponent 1. So 13 minus 1, you get the 12. Okay. But then right here, can I actually simplify this one more step? Yeah? Not yet, not during the lesson. Okay. Can I simplify this one more step? Yep. You cannot reduce a number. Yeah, that's okay, but good try. Good try. It's okay. That's why we're discussing it as a class. I could actually simplify this one more step with the negative. Because the negative is inside the bracket with an even exponent. So my final answer will always be positive. That's right. So I could actually simplify this to simply 6 to the power of 12. Okay. Let's say, okay, so with the same reasoning, let's try 16. Okay, I have an exponent raised to another exponent. What did we say we should do? Gavin? Okay, so what's my final answer here? 36. Say that again? 36. 36. Do I just write 36? No. Like -6 Right. Okay, so I've seen this on the on tests. Okay, I know that you know to apply the exponent rule, but then you just leave out the whole base. So is this what I write? Again, brackets, and then I can simplify this too. Sydney? 6 to the 36. Because again, negative exponent, even exponent. What if this was 35? Can I drop the negative? No. All right. Because if it's an odd exponent, the number will stay negative. Okay. Picking and choosing questions that go over. Okay, algebra. Algebra. Okay, let's go over this first one first. How many terms? Okay, so on page 4. Page 4. So just on the right side of that page. Okay, and again, for those who just joined my class, my lessons are usually capped at 20 minutes. So so that you guys won't feel too bored. You guys can focus on the lesson. And then, yes, after the lesson, you can go to washroom, get a drink of water, and all that. Okay. How many terms is in each of the following? Gavin? 3, yeah. So number of terms is based on the adding and subtraction sign. That's what separates. So this is what separates each of the terms, the plus and minus sign. So in this case, there's 3 terms. All right. What about this one? How many terms is here? Sydney? 2. Yeah, because again, the minus sign, so that means this is 1 term, this is 1 term, so I have 2 terms. All right. Now, here's a tricky question. What about this right here? How many terms do you see? Just based on the question. Just based on the question, how many terms do you see? Yep. Just based on the question. You're right, but By just looking at this line right here, how many terms? Yep, 4. Yeah, that's right. I have 1 term, 2 terms, 3 terms, 4 terms. But Jonathan, where did you get 2 terms from? Because there's 3x and 13y. Yeah, so notice these x here and the y's here. What are these called again? Anybody remember from grade 9? Tayden? Like terms. Excellent. Good. You guys remember from grade 9? Okay. So like terms, I can always combine together. I can add and subtract them. So 3x minus 2x is just 1x. You don't have to even write that 1 if you don't want to. Up to you. I don't mind if you write it. And then negative 13y minus 4y, you get negative 17y. Right? Can I combine this anymore and say negative 16xy? No, because if I could, then what was the point in separating them in the first place? Okay. I remember some of you were in my class last year and I was saying apples and bananas. So separate the apples and the bananas. Don't mix it up into a fruit bowl. Okay. Number 2. Who has the answer for me? What does this equal? Even if you can give me the coefficient. Don't be shy. I know you know it. I'm gonna pick on people then if you. Sedan, what did you get for this one? Negative 4x cubed. Excellent. See, I know you guys know it. Why are you guys shy? All right. I'm multiplying. The brackets means I'm multiplying. So negative 3 times 4 gives me the negative 12. Where did you get the x cubed from? Where did the 3 come from? Yeah. And then so because I'm multiplying, just like what you guys said earlier, we add the exponents. So that's why it's x3. Good job. Wow, okay, let's try this one right here. So what's my coefficient? What's the number? 30 divided by negative 3 is? Yep. Negative 10. Negative 10. And then what do I do to the exponents here? Yep. So what's 2 minus 7? 2 minus 7. Negative 5, right? There is a difference. All right. So negative 5. All right. So this is what I was talking about earlier with the negative exponents. Negative exponent means you flip the base. So right here, my base is x. If I flip it, what is the flip of x? Okay, so you can think of it as x is x over 1. So when I flip it, it is 1 over x. That's right. And then my exponent now becomes positive 5. Okay. What's 1 times 1 times 1 times 1 times 1? 1. Yeah. And then times it by negative 10. Yeah, negative 10. And then what's x times x times x times x times x? x5. Good. So that's my answer. Okay, so this one is a little tricky because of that negative 5. Let's see. Okay, so let's try another example of that. So 8. Alright, so first off, let's reduce that fraction. Negative 42 over 60, what does that reduce down to? Gavin? Sorry? 7 over 10, you divide by 6? Yeah, I like that answer. 7 over 10, good. All right. X. What does X simplify to? X to the 2. Yeah. 6 minus 4 gives you the 2. What about A? I'll zoom it in a little more. Jonathan? -4. Again, because 4 minus 8. So -4. And then what about C? Yep. Ooh, careful. 0, right. You were getting there. Okay. I'm just writing this because I'm showing every single step. Okay. So 7/10, x to the 2. X to the 2, I can just write it beside it if I want to. Or I can write it to the numerator. It's the same thing. So on the side or on the top. Okay. Just like what we were talking about up here. Okay. So what is a to the -4 then? A to the -4 is what? Yeah. Okay. Thank you, Andy. So 1/a. What's my exponent? 4. Okay. And what is c to the 0? Yep. 1. That's right. Okay. And because anything times 0, sorry, anything raised to the 0 is 1, and anything times 1 is just itself. So right here, notice the c cancels out. So technically, you don't even need to write that. You don't need to write this. You don't need to write this. You could have just simply wrote that. All right. Are we done simplifying everything? Nope. We can make this a little nicer. So 7 times x squared times 1 times 1 times 1 times 1 is just 7x squared. Oh, sorry, 7x4. Oh, square. Yeah, it is square. 7x squared. Yeah. And then on the bottom, what's my denominator? Leandro? 10. Leandro? Just 10? What about the a? A to the exponent 4. Good job. All right, now that's a good final answer. The key here is, remember, your exponent applies to both numerator and denominator. Okay. Any questions so far? Okay. Oh, did you have a question? No? Okay. Let me pause the video for a second. All right, number 19. One last example right here. Okay, this question will summarize everything that we did today. So if you understand this one, it should mean that you understood today's lesson pretty well. Okay, so this -3 in bracket xy raised to the power of 3. What does this first bracket give me? Dallas? This one? This first bracket? So what's -3 times -3 times -3? -27. Good. Okay. Because of the bracket, it means that the exponent applies to everything inside. So each of these terms. So then I will have x to the power of 3, y to the power of 3. Okay. I'm not doing anything with this yet, so we are just going to copy it straight down. And then here, I'm multiplying. So minus, who can tell me what this simplifies to? This third term. Let's say Andrew. How about you? If you're not sure, you can pass too. Oh, okay. So, Andrew, here I have the -2. What do I do to the exponent? Add them, right? So x to the, and then y to the 3. Good. All right. Is this full marks? No. Okay. Gavin says no. Andy says no. Why not?
It could be simplified more.
Right. Which these two are like terms. Notice as x cubed, y cubed, x cubed, y cubed. So they're the same thing. So since they're the same thing, I can combine them. -27 minus 2, -29 x cubed, y cubed. And then here, I can't combine it because not everything is the same. So minus x4 y cubed. Now is this my final answer? Yes. Okay. It looks weird, but that's all. That's all it is. Okay. So one final thing, just the terminology. What does sum mean? Yep. Add. So when you add it, you get, oh, sorry. So here it's just saying it wants you to do -3a plus 2a. So sum means add. And what do you get when you add them? -a, -1a. Okay. What about product? What does product mean? Andy?
It's multiplication.
Times, right? So -3a times 2a. And when you times, what do you get? Kevin? -6a square, because 1 plus 1 for the exponent. Okay. Remember this, when you add or subtract like terms, it stays as that. So the apple plus the apple is still the apple. But when you multiply it, that apple times another apple, you get a pineapple. Okay. So that's it for today. 22-minute lesson. Okay. Your homework for the rest of the class and today, you still have a good 35 minutes to try the question. So up to page 5. Okay, up to page 5 is your homework. Sounds good? Okay, so I'll come around to help if you have any questions, and let me know. Put up your hand. Otherwise, that's what we're working on for the last 35 minutes.